Okay, now next is CISC and RISC. These are the different computer organization, we can say, that is based on CISC and RISC. So a CISC, it's a computer with a large number of instructions and is classified as a complex instruction set computer, that is CISC. So what is goal of this CISC? So goal is to provide a single machine level instruction for each statement that is written in a higher level language. So suppose in a higher level language, I am using this variable a is equal to b plus c. So for this one line, I must get one machine level code, that is instruction. So in one instruction, I must be able to complete this task. So this is the goal of this architecture. So example which use this is are VEX computer and IBM 370. Now where RISC, that is a computers should use fewer instruction. So it is based on this concept. So computers should use fewer instruction with a simple constructs so they can be executed much faster within the CPU without having to use memory, right? And this type of computer is classified as a reduced instruction set computer, right? Fewer instruction, simple construction, right? The format is fixed and it can be executed much faster without accessing memory often, right? And in previous videos we have seen that RISC, that is based on load and store instruction. Whenever you want any data, that data first from memory will be loaded into registers and then the operation will be performed. While in CISC, right, the data operation that is performed in memory only, right? It can be brought to a register, you can perform that, but direct to memory, that is also possible. Now let's see the characteristic of each. So for CISC, the characteristics are as like this: a large number of instruction in CISC, because for each line or statement in high level language you want to convert into machine level language. So we require so many instructions, right? And it ranges typically from 100 to 250 instructions. Some instructions that perform specialized tasks and are used infrequently. That is also in this CISC, right? And those instructions we are not using frequently, but those instructions are there in CISC. A large variety of addressing mode, because it may be in memory, it may from memory you will again get an address. All possibilities are available in CISC, right? That's why it's complex. It's a variable length formats because you have different addressing modes, number of address field will vary. So you have a variable length instruction format, right? Your instruction may be 4 bytes, 5 bytes, so that may be vary. So instruction that manipulates operands in memory, that is also possible, right? That is also available in this. So these are the memory location, and we have our data suppose here and another data here, and the result we want to store here. So directly you can take the data from memory, sum it and store the result, right? So you can see there are 3 memory access here, and to access this memory, that is very costly, right? Very costly in terms of CPU. Now characteristic of RISC. So relatively few instructions, right? We have a limited instruction in this, right? The concept is use fewer instruction and get faster execution, right? Second is relatively few addressing mode, right? Memory access is limited to load and store. In the previous case, right, when we want to access A and B, we are directly accessing and storing the result. But now in this, what we'll do, we first store that data from memory to register, right? And then CPU will perform the operation in between registers. And after performing operation, when again you want to store the data in memory, and using the store operation, you can store the data into memory. This is load and this is store, right? So all operation done within the register of the CPU. So in RISC, all operation means addition, division that you want to perform, that is help of with register only, not direct memory operation. Having a fixed length and easy decode instruction format. So the instruction length is fixed, and that's why the decode operation that will be easy. Single cycle instruction execution, right? You can execute your instruction in single cycles. There are different phases in your instruction, like fetch the instruction, decode the instruction, and execute the instruction, right? So you can overlap these phases. Like suppose the second instruction that is in fetch phase and the first instruction that is in decode phase, right? You can overlap this, and this way you can complete the instruction execution in one cycle. It's a hardwire rather than microprogram control, right? Rather than programming it, the hardwire implementation is there, means fixed implementation. That's why it will give you a faster execution. Next is a relatively large number of registers in the processor unit, right? Because all operations are performed with the help of registers only. From memory, you load the data into registers. So we require large number of registers. And it use a overlap register window, right? The suppose 64 registers are there, so it use the concept of overlap registers, right, to speed up the procedure call and return. Because during procedure call, what we do, we pass some parameters. So with the help of this overlap register window, we can easily pass those values. And while returning it, after performing some operation, we want to return some value, right? So at that time also, this overlap register window will help, and it's have a efficient instruction pipeline, right? Due to the overlapping of instruction phase, and the compiler support is also very good for this instruction, right? For efficient translation of machine level to your high level language to machine level language. Let's see the concept of overlap register window.